I alluded to on the outline, and I kicked you guys what I have in mind, and of course you guys can twist that and stuff all over the place. What I haven't, I mean, you can't wash my face, Mike. It doesn't work that way. We may look close, but no.
Michael,
Do I have a spot on my
mic
nose
is,
or something here, Mike?
It was dirty.
Yeah.
you were not muted.
No, you're now
Oh,
visually or otherwise. Yeah. So my idea was, yeah, see, this is why Mike and I work so well together. It was fun during the multiple years, decades. Here we go. So what I'm thinking about doing is getting into lists pretty heavily, talking about is I really think lists are probably the poorest, most poorly taught component in online workshops and in almost every textbook I've ever looked at. And so I'd like to talk and discuss and show you some ways that I think would make it better and radically easier for our students, for your students, because you are my students, that's the only ones I got nowadays. So then, and go into that and talk about variations on that. If we get sidetracked into something else, because that's what the group wants, that's cool by me too. All right? So anything general before I start, taking over here? Okay, so where we left off, just to review that stuff, we left off with those two questions. Where, as I said, the intellectual leap is what I really think that we really need to think about training our students. And every one of us, depending on your background and your student's background, that leap can be completely different from each other. Mike would do it in his Cisco networking with hardware, and he was really into number theory. So he frequently did some stuff, really quirky, twisted things that the students really got into. Mine, I had none of the networking hardware stuff, but we did others. So think about that relative to your own things. So you might steal what you got from here, but then tweak your own way. But the idea of going from the test of constructs and saying, yeah, we solved this problem with 100 students, output the average, that was easy. Or give me an unknown students and tell me what the average grade was there. That was easy. That was the test. Now, all I said was, all right, input 100 student score and output how many students had a score above average. And only solve it using the tools that you know. Remember, you guys came up with both of them. It was cool. The conversation was exactly what happens in the student class. And that's pretty good for adults, because adults usually, I think one of the benefits of spreading this over weeks is that you guys actually started opening up, because if I'd done all 4 of these things in a row, you still wouldn't be saying hardly anything. But the fact is, you guys got into it just like they did. The 2 options, 100 variables, or get this information from the user twice, right? And we said, do those work? Yes. Were the benefits? Yes. Were the deficits? Oh, yeah. So in order to get rid of those deficits, we now say, what did you want from me? What do you want me to teach you that solves that problem? You see, there's the leap. Not only the grasp of stuff that we try what we know to solve stuff, because if it works, fantastic. But if not, I need to find this, either from a source or my own research. So therefore, we look at practical things that they relate to, or charts, graphs, things of that nature. We said one of the good things is, gross national product. I have a chart. If I have 10 charts on a sheet of paper, you tell me the title. The title relates to the contents. Now I say gross national product, and as soon as I say that, I can be talking about 150 things. One variable stands for all of those. Now, how did I access each individual piece of that? I now have a title that tells me that this chart, this gross national product or population growth or pollution level or poverty level or whatever we may be. How do I access an individual piece of that puzzle then?
Store it in a list.
What's that?
Tim said to store it in a list.
Okay, well, that's a list. So we've got this thing called gross national product. We've got this chart, this list with all the stuff in it. But how do I get to a specific piece of that puzzle?
Read it.
But how do I know which one you want me to read?
You have to number them.
Yeah, you have to number them, or you have to have an index or an address that goes with them. When I first taught this, when I first was teaching arrays back in the early 80s, the high school students got it pretty good, but I was also teaching communities, Chemeketa, and a lot of adults, and arrays just killed them. And I kept trying to find a metaphor, and finally, for older people, it worked really well, because I was just saying, you have a street. If I want a house on a specific street, and frequently in the old days, great streets had names that had some meaning, right? They still, some of them do. We had Oak Street, we have Capitol Street, we have Front Street. So therefore, the name of the street described that street in some way, shape, or form. So therefore, if you're telling me I want to get to someone's house, if you tell me it's 512, I go, that's nice. There's a whole bunch of 512s all over the place. That doesn't do me any good. So what does me most good is to say it's go to Oak Street. And on Oak Street, we go to 512. That also helps because two things. If we choose good variables, when we get talking about the syntax and the other structure, good variables resolve an insane amount of mistakes. And when I say insane, I'm not kidding. When I create a list on the AP test, when they used to have two levels of tests, A and AB, the crossover question, the question that was on both exams, so on 75,000 exams, was the array problem, the list problem. And it would be missed by stupid mistakes by probably 3/4 of the population. And I could tell that what was going on is that they had never really grasped that choosing a variable made sense helped you. And two, they didn't have a visual grasp or a metaphor for this whole concept. And that's what I want to get for you guys. Okay? So a chart, and then the year or the number that goes to it, or a street name, and then the address that goes alongside. So index or address is the stuff that goes along with that. So that's it visually. Okay? So if we have that, that's a tool I want. I want a variable that stands for a whole bunch of junk. And then if I want to get to one piece of that junk, you just give me a number and I'll go to that spot and pull it out. Now we all have that. And if I was doing this with the kids, literally I would have them opening up their econ books or whatever they have there and put them out and talking about it and having them looking at charts right off the bat, right? That is what I need to give you. Now, if we're doing that, what we have is, it's just like a problem. So now how do I, the next stage, I now have a grasp of a tool. The first thing I need to do is when I read a problem, how do I know that I need to pick up that tool? How do I know when I read something that I need an array or a list? Just like how do I read a problem and say, aha, I need a loop? Because once again, and this is the only benefit, other than being masochist and causing yourself pain for correcting thousands of tests, is you begin to see that kids really didn't get that. They would use an array to solve a problem that didn't need one. So there'd be a whole lot of stupid mistakes they made because the syntax was harder. Or two, they would try to solve a problem that needed an array, and they would work like crazy and never get a solution. And textbooks don't do that. They just say, here's a bunch of problems, solve them. All right, got it, good. So what do? My quizzes, my tests, every single one of them, I tell them right up front, day one, your quiz or their test at the end of this chapter, and I usually gave them like, here's 5 problems, you got to solve 3 of them. But I would put problems on the array tests that didn't take arrays. And if they solved it with an array, they lost points because it wasn't efficient. And we'll talk about why. I don't care if it worked. That doesn't make any difference to me. On my exams, what matters is the best solution. And therefore, if you use an array when it wasn't necessary, you lost points. And of course, if you tried to solve a problem that needed an array without one, you wouldn't be able to solve it. Or else you'd come up with one of our 2 earlier answers that were so insanely inefficient that you would lose points that way. All right, so tell me, many of you have the idea you've done lists or arrays in the past, others of you haven't, and it's almost better if you haven't, because like I said, I think one of the reasons why, number one, I'm a teacher, I'm not a programmer. There's a whole lot of people way smarter than me in computer science. Lordy, I'm not I got math up a lot, but I'm only a mathematician in the sense of being a teacher. That's what I am, as a teacher, not the other stuff. So there's a lot of people smarter than that, than me in any of those realms. But we are teachers, and so our thought is how do I get this across to kids? And so if you are brand new at this, there's actually benefits to that. Because just like Johnny said the other day, keeping a journal kind of, you might write down and say, this was really tweaky and this is what I screwed up on, so that when you teach your kids this, you can actually even personalize that. It'll make them feel a lot better. Because frequently the ones that are on the border feel they're real stupid because they are not getting it. And they would never think that they're a brilliant teacher. I'm sure that's what they think of all of you. I don't ever think anybody ever thought of Judson, be quiet. So here we go. So ever thought of me that way. But the fact came out to be is that what if you make a mistake, there we go. So this is good. So tell me, when I read a problem, how do I know I need to pick up this list tool? Because if I don't know that, there's no point in me telling you how a list works unless you know you need one.
So I can think of 2 instances where I would need one. Can I tell you? So the first one is if you are handing me content and I cannot just hold it within one variable. So I almost think of it in a physical way, like you're handing me a bunch of stuff and I can't carry it with both of my hands. So I'm going to need a place to store all of the things you're throwing at me, all of the information you're throwing at me.
Okay, well, Johnny, if you don't mind me taking this one bite of banana, so I'll take that one for a second.
Okay, sure.
And then if you can hold on to the second one for me, if you don't mind. Okay, and I'm going to do to you guys the viciousness that I do to my students. Like I said, by this time, they're used to me, and as we don't get paid enough financially, we got to get some satisfaction. So the sadistic joy of teaching, I just tell them that's what number one, I want you to get great jobs because I want you to pay for my Social Security. And number two, I get the joy, I don't get paid money, so I get the joy of causing a whole lot of pain to other human beings. So I got to get something out of this gig. So here we go. So I'm going to play this game right now. So Ranjani, let me give you this. You're saying, what if I read a problem and it has a whole bunch of stuff that I can't hold on to, I need an array. Right? And that sounds kind of logical. So here I am being vicious. I'm going to give you a problem and you tell me if I need an array. So I have a company with 250,000 employees and I want to know the average salary. Do I need an array?
Yeah, but your problem did not require you to hang on to that information.
Oh, okay, so good. I need a little clarification. Perfect, no problem at all. Good, good, good. I like the smack back. Your hand, instead of raising your hand to be nice, I always thought I wanted to develop a 3D computer screen so that you could go smack. Usually it's from my point out the other way, but in this case, I think it would have been the other way, obviously, by the tone of voice here. I love it. So what do you mean by holding on to it? I didn't get that. When do I have to hold on to something? Because I gave you a problem, I need an average honor, 250,000 salaries. That was a whole bunch of them. I couldn't hold on to them with my hands. But what do you mean I didn't need to hold on to them?
When you need to reference the content repeatedly in different ways.
So what, oh, okay. So let me give it this way. So if we do an election and I have 3 candidates and I'm running that election, do I need an array? I want to find out who won the election. So I got to hold on to their, do you see? I got to hold on to their votes, right? I got to hold on to their votes. So I got a whole lot of voters. I got millions of voters. Do I need an array to do that?
Does
In
it
that
depend
case, you
on,
can aggregate.
What's that? Tim?
You can aggregate the data in that case.
So that good. So do you see what I'm doing here? Do you see what I'm trying to really get down? I want this to be very precise in their minds, and in this case, your minds. When I read any problem, how do I pick out of that? And by the way, you have a different population than I do. If you can use the word aggregated and it makes sense to them. Maybe you do, right? But that's the reality of it. Do you see what I mean? It may be. So therefore you need to, so what, how do I verbalize it so that you force me? I can't come up with an example that doesn't work with your verbiage. You see, that's our goal, isn't it?
You gave us an example last class.
Oh, well, so let's verbal. What do you mean by that? I know I gave you a good example that twisted that. So how do you verbalize the rubric, the algorithm around that that says if this, if I read this problem and it fits this stuff, I must use an array and there's no way around it. So how do I verbalize that? I'm not saying you haven't, but I'm saying if I was a student, right now I still don't think I would have it. Teaching isn't easy.
Does it
That's
have
what
to
you
do
suck
with,
a sucky job on it. Yeah, I'm sorry, Cece.
does it have to do with whether you need to compare the data? Like use the data within itself instead of just adding it up or something like that, but
Like order.
You have an idea coming here. I think we have. I always call it you've wounded the answer, but the sucker's still walking around.
You
Right?
need to process the data.
We've bounced off the answer a whole bunch, but we haven't kind of put it in a tight bundle yet.
From Cece's words, I gather, okay, comparison is a good word. That's one instance. Another is a search. If you're
Yeah.
searching for something or comparing stuff, anything that involves interaction among the data values.
Okay.
I think if you need to access the individual elements of the data, then you're going to have to put it in a list.
Like,
Yeah.
I'm wondering about alphabetizing in particular. Like, if I'm trying to alphabetize a list of names, that wouldn't be something I could turn into numbers and do in a different way, I guess.
Now, what's interesting, if you guys listen to what's going on, you have listed about 3 or 4 or 5 situations that an array or a list is required. So one way is for students, if it is, we could do that, we could compile a list and say, if the problem is one of these 10 things, we must pull up an array and hope and pray like crazy that whoever's making the stupid exam up, my graduate exam, doesn't come up with a problem that doesn't fit on my list. Now that is an appropriate approach. And for some students, it's a very effective approach, right? But if we can come up with a more tightly bundled, quick little check that says, if I got these things, we started, well, Rajani, when I on purpose, sorry about that, but kind of misinterpreted or didn't completely interpret Rajani saying, I said, we have a whole bunch of numbers. And I said, hold on, we got 250,000 and we want to know the average. Did I need an array? And the answer was no. Right? I could do it easier just with a nice little for loop. So if we can make it simple for our kids, we got it. So how can we pull up? So we've got something to do. And then I turned around with the election and I said, we have 3 people. And did we need an array? I'm redoing the data. I'm having to come back to it. I'm doing that. Did I need an array for 3 candidates? No.
Well, is this have to do with having, we need data of the same type? Like we need 4 names or 4 numbers or?
Okay.
I'm not really sure what the question is.
So the question is I'm trying to figure out a simple little phrase or structure that a student could look at any problem, read that problem and say, aha, I need to pick up the array of the list tool. I need to do that.
Oh.
I want it to be very concise because if it's concise, the students can use it and will use it. Right?
I mean, I know what my own test is,
Okay.
and that is if I have to write more than X lines of code to store this information, then I'm going to use a list.
Okay, so good. Let's work that backwards. When do I have to store? And you guys have hit it several times, kind of. When would I have to use? And there's 2 pieces of this puzzle. You guys have actually mentioned, I think, both pieces in sideways ways. When would I have to do that exactly right? And when would I have to do a whole bunch of code to be able to access this information Because if I only had 3 candidates, that was not enough to worry about, right? I could just do 3, if it's candidate 1, else if, else, right? Done.
If you're looping, if you have to loop through the data,
Okay, but if I did good, no problem. This is good. There's nothing wrong with what we're doing, because isn't this the conversation that kids would come up with? Isn't it? And this is what a textbook, what an online course cannot do. And by the way, what we're doing right now is exactly what you do if you're a team at Microsoft or Google or Intel. When you're solving a problem, this is what you're doing, right? You throw out the problem, you start brainstorming and attacking it from all over the place. And some jerk guy will come up, sorry, but it's reality. Some guy will, oh, I don't know, and try to blow everybody out, and only people stand up and say, no. Number one, this doesn't make sense to me. And number two, I think this is the better side approach. You're skipping this. So here we go. Yes, Michael.
So don't answer the question if I'm changing the subject, but you and I had that conversation one time about how because of the speed of the processors now and the number of switches we have, that we used to have that question of speed. Are we making our program so complex or so inefficient that we're wasting processing time? We don't really have that question anymore. So Mike, I always wanted to ask you, why do we even bother with arrays? Why don't we just use lists for everything?
Well, lists and arrays are the same thing. I mean, they're just another, I'm not sure, lists are Python's version of an array. They are the same thing. So I'm not sure what your separation is right now.
I thought in a list we could use different types.
Oh, well, that's a piece of Python and has nothing to do with language.
Oh.
That's the difference there. So yeah, okay.
I'm
You're getting
sorry.
ahead because you know some other junk. So that's an independent piece. Back to this. So we
Okay,
can go
Don,
off this, yeah.
so you're trying to come up with a criterion based on which we can decide whether we want to use the list data
Correct.
structure or not.
Correct.
So why don't I throw your example back at you from last class?
What? No, that's not fair.
And say, if you have to ask the user for the information more than once, then use a list.
Okay. Okay. And would your student, now, by the way, I'm not negating any answer here. What you need to do is thinking about your students and putting it together and say, if I read any problem, by the way, one of the ways to test your phrase out would be where I printed out all these codes. There's a whole bunch of codes relative to arrays and lists here. So what would be good is for you to go back and forth between the codes from constructs and the codes from arrays and say, would my criteria work? On these problems, the answer would be no, and nope, I didn't need it because I do this. On these problems, the answer would be yes, and you see, so whatever verbiage you come up with, test it out. And so, because my verbiage is not the right answer, it's just the one that works for me and my kids. That's the way it works. So I'm going to kind of give you my summary, and then you'll go, what, you cheated, Kirkwood. We already said that, and that may be true, but it was so much fun just harassing you, so that was okay. So mine comes out to be twofold. Is if you combine the two, one is 250 salaries and output the average. I didn't need it because I didn't need to reuse that data. But two, the one that I did need to reuse that data, like 3 people and a candidates, I could do that because I only had to have 3 variables and it wasn't enough to worry about. So if I mess those two, if I say I have a large group of similar info, like candidates or salaries or employees, when we get to classes, this becomes bigger, and I must use that data more than once. If I had said, that's why the problem I gave you worked, right? Because we had to use all the data to calculate the average. Then I had to go through all the data again to find out if their score was above average. So I had a large group of similar information that I had to use more than once. I had to use it twice. If I had 10 candidates, I wouldn't want to have 10 variables to find out who won this election. So large is the relative term. I would have created an array of candidates and done that, right? You see that. So that's my criteria we came up with. Large group of similar information used more than once.
So what about your example where you we're going to find the average salary of 250,000 employees. I mean, don't you have to think about the user a little bit? Like if your program asked me to input 250,000 wages, I would go find a different program.
Well, but some place at some point in time, no matter what you did, you had to do that. Right now, notice I didn't say user input. It could be from a file. It doesn't make any difference whether it's from a file or from a user. Still the same issue comes up to be. If I want to be not using sequential access on a file on some structure someplace, if I want it in RAM, I want to pull it out, even that 250,000, I got to get the information somehow. So if it's from a file, I just do the right, a for loop 250 or end of file to whatever it is. And so I don't need an array because I only need to use it once. I just needed to use it to add up. I never would need to go back to employee 25 to find out what their salary was again. I used it once. So I see what you're saying, Cece, but that issue is independent of do I use an array or not use an array. That's another side issue.
I have a question, and this might be a tangent, but I'm wondering with the problem where you had someone inputting, say, 100 scores, and maybe you wanted to just not only do the average, but do something else with that information as well. An array would make sense. Is there a way for the user to input to an array?
Yes.
Or is that just a tangent?
Yeah, right now what we're doing is we're building this up. First of all, we're saying, what do I need? The tool we needed is this new thing called an array or list. Okay, those are synonymous. And all the other languages, we call them array. The syntax in Python, they call it a list. So that's what I go back to it. Then second is, when do I need it? And now that I have this new concept, when do I need it? And now the third step is going to be exactly what you're alluding to. How do I now actually code this process? How do I make this thing into Python? So that's what we're leading to next. So to me, for our students, frequently what it ended up being, I said to all my students, never write down what I say unless that makes sense to you. Use your version of it. I don't give a rip what you say, how you label it. Matter of fact, if it's good, I'm going to steal it from you because it's probably better than mine. But it just came down to the simplification was, I have a large group of similar information used more than once.
Don, I just want to ask about the one word you used to describe the situation. You kept saying similar information. Is there a large group of dissimilar information where you would reuse the data, where you can't use a list?
Well, but then, yeah, because you could not have, it's dissimilar, like we had scores and we had names and we had bowling averages and we had, right, if you had different radically, then we couldn't put that into a collection. Well, there are some tweaky versions thereof, but that's a whole separate beast. We would have to make separate charts to handle that unless there's some like C as a special tool you can use, and there's some other versions. But at this level, no. So that's why we kept saying similar. It means I have a bunch of students and I want to know their average, or I have a bunch of employees and I want to do this with it. That's why the similar comes into the frame of reference. Make sense?
Yes,
I
thank
think
you.
part of the reason you don't put dissimilar information into one list is writing code to process that information becomes extremely challenging.
That's why, yeah, there's some languages have some special tools, advanced tools that make you allowed to do that, but you're exactly right. And files don't work that way. We always put all employees into this big file thing, and then we do something, and that's exactly right. Just to separate different kinds of things within a collection is really tweaky. And we just don't talk about that at this stage. All right? So what we end up doing, therefore, is, and I'm going to kick back to the board, I want to talk about generically setting this up, and then we're going to talk about the beautiful tools that Python sets in there. So we're going to try this and see what we got. That should be clicking on the one time we didn't. There we go. So when we have this collection of information, we have our chart. Now, one of the most common mistakes by students is labeling these charts. And the fact comes out to be is this is therefore radically more important by choosing good variables. We already talked about internal documentation, all that stuff, choosing variables that make sense. If you use an X and a Y on my programs, you're gonna lose half a point unless we have to be talking about coordinates, because X and Y have absolutely no meaning relative to anything else. So most textbooks or most online stuff really are pitiful at that. With arrays, it's even bigger problem. Like I said, Mike Dunlap used to call this a second level of confusion. So our goal is to make this so it's not confusing. Otherwise, they're going to make some unbelievable stupid mistakes when we do get to the syntax. So when if I had a bunch of charts on a page in the book, an econ book, how would I know, and we talked about this earlier, how would I know which chart to go to? You have an economics book with a whole bunch of charts about countries and governments and all that stuff. So if there's 20 charts of this, how would I know which chart to go to?
Glossary, index, table of contents.
No, but they're good. You're right. But let's assume, to make it simpler, they're all on one set of page. We're sitting looking at 2 sheets of paper in front of us. We open up a book, and there's 20 charts on this page, on this book. And you, the student, want me to go to the one you want. So what would you do? Now this
They have a
seems
label.
almost too simple, but it matters.
Well, they have a label, right?
They have a label. They have a title, right? Now hold it, and you go, duh. But the fact comes out to be this is not a duh because I've corrected thousands of codes and the kids screw this up constantly. What does that title or label do? I mean, or how did the author of this book pick the title of each chart?
Chronologically, usually they're like as a number and a letter chronologically in textbooks in particular when you have diagrams.
Okay, I'm saying, but remember if we had a whole bunch of different charts on this thing in an economics book, so it had all the, and I'm trying to be really obscure because I don't want to give the answer away here. So I just have a whole bunch of charts that deal with statistical stuff about governments and stuff. How would I know you as a student want me to look at a specific one of those? And you said there's a title or label, so I assume that's going to be up here. What does that label, give me an example that that label would be if this was economics.
So like 1C, gross national product of Ireland.
Oh, okay, hold it. Now we get, see 1C I don't get. 1C doesn't make any sense to me. You tell me that. But if you say, go to the gross national product chart, I would go, oh, okay, I can go to the GNP here. Now, why did they call that GNP? There's method to my madness here.
Because it's not as long as gross national product.
Oh, it's smart mouths. Why would they call it that? Why would that chart be called GNP? Are you guys seeing the title? I can't remember. It's probably, is it too low? There we go. And this is almost too obvious, but it isn't.
Because that's what the data in it is.
Thank you. Thank you. And this is huge. You might go, duh, you airhead, of course. No, I have taught for 40 years and there ain't no of course here. The students constantly screw this up. And when they choose their variables for their code, they will get these backwards. So yes, the contents in here is the gross national product. The other one over here, if it's called population, is the population. So the title of the chart describes the data in the chart. That's, right now you go, well, duh, just wait. If I don't give you any more future hints, I'm going to let some of you stub your toe pretty good. But I'm a nice guy, so I'll probably help you through that place. Because I don't want you to know, hey, Jackson, they can see your face. Don't be shaking your head that much. You're right, but that's okay. So what situation is this? The title references the piece of the puzzle, what this is, the contents is. Now, please tell me down the line here, and by the way, they always start out with 0 in these languages. The first spot starts out with 0. Now, if we have this, let's go back to our concrete example, since we did this one all the way, and it's easy mathematics behind it. What would the chart be for the problem we jumped into in the first place here. So it'd be from 0 to 99. As I said, so our chart, the problem we used to make the intellectual leap, what would be a good title for our chart? By the way, there's not one, there could be 5 or 6 or 10 good titles for this.
Is this a grades one or is this something different?
The grades one, yeah.
Grades.
There we go. There we go. That was tough. Here we go. Yes, exactly right. So this could be grades. It could be scores. It could be percentage. It could be anything like that, right? There's not like an answer, but whatever the answer is, it's got to describe what is inside of here, right? Right? It's got to describe what is in there, correct? Now we have a second piece of this puzzle. And this number one is that students will do this, and I'm going to get you in a second. You'll discover I will get you in a second with another example will come with, always happens. So here we go, but we have these numbers over here. By the way, if I look at those numbers over there, and I'm now talking about accessing and doing this stuff, what sort of loop structure are we going to be using frequently here? Starts. What search am I going to probably be using?
Well, the problem is we had designed it was an artificial flag, but I'm guessing if you already have the grades and you're just dealing with the information that you've already compiled in your list, then we're probably dealing with a for loop.
Okay, because at some point, why? Let me backtrack. Why do you say that?
Because you know how many data points you have.
Yeah, you got this chart, and it's got. If you're going to put this chart out, you got to know how many bodies there are, right? Or how many whatever there are. So therefore, by the time we make this chart, if I'm going to use this chart, I know how many elements are in here. So that's going to be a nice little foreshadowing to when we start doing the coding that we're setting up some stuff. But what I need to do therefore is I have a for loop, and unfortunately, most textbooks would go for X in the range of 0 to 99, which sucks bad. It's just pitiful variable. Students are going to stub their toe everywhere doing dumb things. I say that this thing over here, the addresses, like I said, if you have the street metaphor, this is Oak Street and these are the houses down there. It makes sense. This is the street name and these are the addresses, or you'll get index or indices, plural, and so forth. There's a lot of jargon for this stuff on the side. So use whatever's appropriate for you or the kids. But the variable that goes along with those things is as important as a title, and you're going to see that when we get into the code in a second. So what do you think would be appropriate? So tell me, if I wanted to get to 92, what does 92 actually reference?
A score that the third score that you recorded.
But the third, okay, but be more precise, the score of?
It's a student.
Address 2.
Well, but address, we could do generic, but in reality, you see, the more specific I am, the more meaningful my code is going to be when I start writing things out. When I say good code can be read by someone who knows nothing about programming, and actually they would understand what you're doing because your variable choice and everything else is good. I heard that a second. What would be, this would be the score, the grade of?
The student.
Student. So, and I always say this, we're going to abbreviate that to stud because this is one of the few times the guys in the class will ever see that word applied to them. So we'll use it right now. So here we go. So this is the grade of stud 2, of student 2, correct? Everybody see that? Therefore, and notice what I'm doing. If I read this right, you're going to see the code radically does it. This is the grade of student 2. It makes no sense to say this is a student of grade 2. That makes no sense at all. And yet programmers on the AP test, huge percentages of them write the code that way. And that's what we need to start doing right now. We choose good variables. This is where it works. And if you're helping students, or I have my students help, I say, no, don't help them on the problem until they have drawn and labeled this thing. And on my first quizzes and tests, that's the first, I give them a problem and I say, question part A, draw and label your array needed for this problem, if one is needed. It's really evil when I give them the first problem, there's no array needed, so they say, skip, no array needed. I love that. I love evilness. When you make them think, what a concept. So everybody see that. That's going to be very important coming up for a problem we're going to do in the future. Choosing the title, and the title always does what?
Comes first.
Comes first, but what else on my picture? What
It
is
explains
important about
the
that
data.
title?
It explains the
describes
data.
Exactly right. And it's a good description, a simple description of that data. And what does the index or the address do?
It describes one cell, sorry.
And what you do is you pick one of them out and say, aha, this is a grade of what? So it could be, if this is for one student, right, this could be a grade of assignment. Right? If the problem said I've got a student that I've got all their scores the whole time through, tell me what, and I ask them for several different pieces of that puzzle, this could be that way, correct? Everybody see that? So once again, it depends on the problem. All right, everybody follow that flow. Okay? All right. Any questions before I take the next leap?
No, I'm good.
Okay, so what do we have now? What we have now is we now know we have this new tool called list. We know when to use it. We use it when I read the problem and I've got a large group of similar information and I'm using more than once. And that's pretty, and that may take some, what do? I read off literally these sheets of paper that I gave you with all these problems. I start reading them. I just make up problems and read them off and say, well, all right, do I need an array here? Here's a problem. Yes, no, why? And we just do that over and over and over again, right? Until they get that rhythm. And I tell them, you're going to have problems with the test that don't need an array. And if you choose to use array, you're going to lose points. And so the hot dogs, and several, I know none of you had those students, you know, Judson wasn't one, but there were, you know, there's some others in the class we could ask. But the guys who know everything before you start teaching the first thing, I love, remember, I build walls. I want them to stub their toes, both because it's kind of, I have to hide my smile because it's kind of fun to see them stub their toe. But number two, in reality, it's good for them. Otherwise, of course, I wouldn't do it because that would be just evil. So, so I know when to use this tool, and now I can label and draw it. So now I'm ready to go to it and start coding it. All right? And we have a problem. And you guys, anybody who's looked at a textbook or looked online, please describe for me what they, when you get to a chapter on arrays or lists, what do the books do? They may have had kind of some of this conversation a little bit, not this precise, I don't think, but we've done it. What is, in all honesty, how do they teach arrays or lists? Has anybody done that? Maybe not. Well, well, no, you didn't do it. You learned it from me. Yeah, no,
They just slap that structure on you, and then they create these artificial examples that they would nicely fit into, and then so you never get to really make a choice. It's a bit like how math is taught. Like, here's a concept, here's a test. Now you know you have to use quadratics.
yeah,
But what about when I study quadratics and trig and exponents? I need to know when to apply what, right?
Correct. Yep. And that was the problem when we taught, if we teach algebra that way, when they get to algebra 2 or trig or pre-calc, they die because they never understood the concept. They just memorized a simple algorithm that anytime, rather than being able to expand. Exactly right. And if you do it, that's exactly what I think they start with simple problems and build them up and make them harder and harder and harder. And good students somehow pick it up. Students who don't need us pick it up, and 80% of the class don't get it. And they may get it and they may get frustrated and quit. As a matter of fact, this is the first place where there's massive loss of bodies and or interest, which is a shame, because this is one of the coolest concepts, and the power behind this are just slick. And once we get the basics, oh, you can do the Civ of Aristophanes and the stuff that we're going to pull off and discuss here. oh, they're just so cool. But if you're so frustrated with the elementary stuff, you ain't never going to get there. So you say, I'm not good at this thing, or this thing is boring, this is not fun, and you quit before you get the chance of seeing it being good. More. Those of you who run a lot, no, to me, that's still, I now run because I should and have to, not because I like it. I've never gotten to the stage where I'm good enough at it that I like it. I just do it because I know I should. I need to at my old age, or else I'm going to falter as I'm hiking up to Ramona Falls. So the fact is, that's why I do it. But that's not what our high school kids are not going to be able to do that. So we lose great people because we don't set them up for success. We set them up for boredom or for them feeling that they're crappy at something, so why continue on? While the hot dogs are over here flashing and they're stupid. They really don't know what they're doing either, and they'll suck really bad, but they sure look like they know what they're doing. Right? So here we go. How do I take the next stage? I want to do a real quick aside because I think this example will, many of you will get it in the fits, because I think most of us, more of us have had math classes and stuff and do that. Do you guys remember, and I'll try to do this brief, I want to shorten this one up. Do you guys remember combination problems back in Algebra 2? That's what they always titled. And Johnny, that reminded me so much of what you just said. That's what they teach. And these are the problems. If you remember back in the day, they would go, they almost always would start with, if you have a 10-liter of a 30% acetic acid solution, how much water do you add to that to make it a 15% acetic acid solution? Right? Do you remember those problems? It's something that we all do on a daily basis. So it's great to be teaching freshman or sophomore how to do this, because this is what we're going to be doing with our life. But who said math had anything to do with real life? So, but that's what we do as an example. It gets worse. And so what do we do? We draw a little picture. We teach them how to draw the picture with the water and an X, and we're doing that. And what goes on? So we have our population in our class. We have 10, 20% of the class goes, as soon as I showed them this one example, they go, got it. They never need to see it again, they've got it. Another 50, 60% of the kids are paying really good attention, and now in their mind, they have a category. There's a hanger, I always call it, they got a hanger in their brain that says, if I see a problem like this, this is how I solve it. And they're good. They're really paying attention. They paid attention to details, they got it. And then we got 10, 20% of the people who either didn't pay too much attention, had a hard night last night, or hate math, or don't think they're good. So they kind of get it, but not really. Then what did the book do next? Sure, I love these. Then the book says, you go into a grocery store, and almonds are $2 a pound, and walnuts are $3 a pound. How many? And you want to come up with a 3-pound combination that costs you $1.75 a pound. Now, by the way, do that. Just go into the store and say, I want to buy some nuts here, and I want to pay $1.25 a pound. I'm going to put them together. You tell me how much. Just do that and see what will happen. And they're real life problems. And so what do? We show them this. We show them the example. Once again, now the kids have another hanger. The good, hardworking students have another hanger that says, if I have a problem that's like this, I do it this way. And guess what? There's 3 or 4 versions more of this. And that's exactly what the textbook would do. They would show the different 3 or 4. One is money invested in the bank, some at 5%, some at 7%. I go, you idiot, put it all at 7%. What are you talking about? It's the same bank, so put it at 7%. Why do a part of it? And there's a whole bunch of, there's several problems like this. And so what happens? The bright kids, done. They didn't need us anyway. They just needed us to kind of introduce the idea and they're out of here. But that 50, 75% in the middle, they now have too many hangers. They got too many hangers in their brain. They're trying their hardest. They're keeping them separated. And what do? We're worse. Is we teach them 1 or 2 and then we'll give them a quiz over those 1 or 2. Then we'll teach them another 1 or 2 and we'll give them a quiz over those 1 or 2. And they think, and they nail them both because they're studying, they're doing it. And then we give them a test over all 6 versions and they fry. And when I was first teaching out of German, my second year of doing this, that's exactly what ended up happening. I had a great, phenomenal class. I was doing everything I asked them to do. Every single thing I asked them to do in the leading up to this, they did. Their quizzes were good, and I gave them the test, and they got like a 68% average on the test. And when I graded the test, there was no way that I could say they failed, because they did everything I asked them to do. And I followed the textbook to a letter, but I failed because I didn't teach them. I used the textbook, and that wasn't teaching. So what I did is that day, that weekend, and this is really date me, but because there was no copy machines back in those days, guys. You didn't have the old thermofax machines, guys. None of you, only we real old people know what to smell the beauty of flying high out of our copy machine days. So here we go. Back then, grass was illegal, but this was, you had to do this. So what the heck? Here we go. It's a little fuzzy-headed stuff. But I took my old books, actually, and literally ripped pages out of them and had that. And I took them home. I got my great aunt's table that has like 4 leaves in it, you know, one of those things. And I put all these papers out on this table. And I started rearranging them, trying to figure out, there's got to be a better way to teach this. And what was really weird, I played and played and played and played, and I came up with, it was phenomenal, apples and pomegranates plus apples and pomegranates equals apples and pomegranates. I love your look, by the way. Your looks are exactly what my students did for me on Monday when I came in and told them this. I said, I screwed up. I'm sorry. This test, I'm going to throw it away, but I'm going to teach it to you new. And I said, this is, and they all went, this guy's awful young to really, we really broke this guy. He's gone. We don't know what's going on, but the party's over. I said, no, let me show you what I mean. Well, guess what? The problems dealing with the water and the acid and the adding water to dilute it, we have an amount and we have a percent. So we have 10 liters of a 25% acetic acid solution. We add X liter of waters, which is 0 acid, equals, and we have apples and pomegranates on the other side. So you fill in the blanks. Guess what? The walnuts and the pecans and the peanuts, we have an amount, which is kilograms or pounds, and we have a price. And when I combine those two, we have apples and pomegranates plus apples and pomegranates equals apples and pomegranates. And when we go to the bank and we have an amount of money and we have a percent interest, we have apples and pomegranates. I showed them this algorithm. Now, by the way, is that good in a way? Well, maybe not. Because do they understand the problem any better? Well, no, but they know how to put their ideas together in a way that works.
Well, it's interesting because, you know, a lot of our teachers in high school got very up in arms about us labeling everything with the appropriate units.
Yep.
As a part of the problem. If you didn't get the appropriate units, you didn't get the credit. And I remember a lot of the time, but I got the right answer. What do you mean I didn't get all my points?
Yep.
Because I would turn everything into apples and pomegranates, but I just would not turn it back into whatever it needed to be.
Well, in this case, the good thing is amount is pounds or kilograms or whatever you got. And right on each variable, you have pounds and kilograms and percentage of, and so therefore the labels actually fit together with it too. The labels really help science class a lot more. I love telling them we're showing them problems. That means we have diverse knowledge too. But what ended up happening, I came back and showed this to the kids, and what was interesting is we really want them to understand this stuff, but success helps understanding. Lack of success helps failure and feeling that you're stupid and you're never going to get to understanding. So we did that. I gave them that. The next day, I gave them a radically harder test. I taught them 1 period that way. The very next day, the average score was like 89. They jumped 20%, and there was no change other than they could organize their thoughts in a way that made sense. Now, by the way, what I want to do about this, therefore, is when you came to erase, the exact same thing occurred. When we did a bit ago, that while loop, when we introduced the unknown artificial flag, if I just let you guys fly, how long, or would you have ever come down to an algorithm that said get flag variable, while flag variable, do stuff, get flag variable? Or would you have every single time you came up with one of those problems, kind of had to think out stuff and reapply stuff and try to organize what was going on? Because you didn't have an algorithm, a thought process that worked for you. Now, by the way, do you need to use my words? Absolutely not. I say do it, but you need to come up with some methodology that helps you not reinvent the wheel every problem. Well, guess what? Arrays were the exact same way. Year after year, it took me several years. You would think I need to get hit over the head with a 2x4 before I finally figured things out. Students were struggling with arrays, and yet I kept teaching them the way I learned it, to the way the books were there. And I said, there's got to be something better here. And the worst problems were the following. Here we go. Tell me, first of all, does this need an array? I have the election, and I want to know who, I want to be able to print out. So I have 10 candidates. I want to be able to print out at the end of the election every person's votes that they earned. And I want to know who won the election. And even better yet, I want to know who got second. Right? Do I need an array? Because without the array, I'm back to that whole bunch of bodies with a whole bunch of variables and doing that. So I got a bunch of similar information, and I need to use that information more than once. So yes. Okay. There's an array problem. I have another array problem. I want an unknown number of test scores, 1,000 of them. And as I said, I want to know how many got above average. Or I want to figure out the standard deviation. There's a standard deviation. I need the average inside of it to be able to calculate the standard deviation. I want to do, or I want the median. Or I want the mode, right? All the statistical analysis. Or I want to sort them. I want to show them sorted. Right? Now, all of those are just like a shotgun approach. Let me give you a whole bunch of problems, and you just solve and try to figure out every one. And right now, well, let me give you one more. I'm in the store. I'm a store owner, and at the end of the day, you know, just scan the stuff by. And at the end of the day, I want to know how much profit I made and which items I need to reorder based on how much I have in stock. Correct? Now, if I read off all these problems and I give you a whole bunch of problems, would you be able to, oh, well, let me give you one more. And that is, and I'll just describe that one. I want to deal 5 cards, and I want them to be unique 5 cards, i.e. I don't want 2 aces of spades. Okay? And another one, I want to, and Mike knows this, and I think, yeah, we did, I'm sure, Judson, and that is the Ciber Aristophanes. He came up with printing out all the prime numbers between 2 and 10,000. Any prime number between 2 and 10,000 printed out. Now I just threw at you a whole bunch of arrays, and most of you could go every one of those problems, go, yes, it needs an array because of this and this. Yes, yes. You see what we're doing? And if I was doing this for my students, I would have thrown several problems in that didn't need arrays. The well problem, right? The guy's down the bottom of the well and then you climb up and here we do what's going on. Falling off the dock and throw those in to the mix and said, do these need arrays? Yes, no, because, good, cool, now we'll go by. Now, the problem is that with arrays, we now have this huge pile of problems, this mountain of problems. And what would you, be honest with yourselves, if I give you all of those to do, what would you end up doing? Every problem, you'd probably pick the easiest one for you to see right at the top, first time, and you would do it, right? You'd work your way through that. If you're smart, you draw a picture, you label it, maybe do a little hands-on stuff, you'd rethink it through and then do it. Then you got a brand new problem. Would you do the same thing? You'd start with it almost like an independent event, correct? Because that's the way it was taught. But the fact comes out to be is that there are 3 categories. I did the exact, finally, after many years of screwing up and doing it poorly, I finally said, there's got to be a better way. And I went, oh, when have I thought this before? Oh, I did this once, like 5 years ago. Let me do that again. So I took all the array problems and laid them out. And it so happens, as you look at the notes there, I discovered, and by the way, if you find out another version or a subset that works well, please, please, please tell me. If you'll note, this is on your notes, the week 3 lesson plans. If you have that, look at, there are 3 categories. One is general, and we'll talk about these 3. Another is tally, and the last is Boolean. Or Boolean, depends on how you want to pronounce it. So now what ends up occurring, what I found fascinating is, once again, on my tests frequently, I would give them like 5 problems. They have to choose 3 of them to code. I hate a problem when you have to do this one, and for some reason, that question just doesn't, for some reason, it just doesn't click. And that just seems really unfair to a student, personally. I don't like that, because it just may not make sense to you. It could be because I wrote it poorly. It could be a whole lot of reasons. Now, what are these categories? And let me talk them through, and then we'll talk about why they matter. The general one is one that you do just like you would do the math. You just have a bunch of numbers you're doing something. If I did the above average, right? You just got to do exactly the way you would do that with a math problem. You got to figure out the average, and then you got to go through, and if they're above average, you did it, right? You guys actually talked that through. You didn't think about anything special. You do with the problem, with the array, exactly what you would do with math. The standard deviation, the mean, median, mode, all of those things are of that nature. Okay? If I find the total of my salaries for my company, same thing. If I'm figuring out taxes for every employee and doing that stuff, and I'm going to rip them off because I'm not going to let them pay taxes this year, but they'll have to pay it next year, something like that, so that I don't stop their Social Security taxes. I just delay it till next year, and they'll all save for it. Don't worry about that. If I did something like that, for instance, I would do the same thing here. The mathematics would be right in this structure. General means I just solve it like math. Now, by the way, the sieve, I taught you, I use the metaphor for my students all the time for loops. When there's 3 loops, you take the problem, you dump it in there, you sieve it. Now think about yourself, be honest with yourself. In your brain, if you had a problem that did the loop, what's the first loop that comes to mind, or that you automatically check for first? For almost all people, it is the for loop, right? Right? I mean, intellectually, it's the easiest one to see. If they say it's, not everybody, but most people, sieve is, put the problem is, if it's got a concrete number that I'm going to do for loop, done, I don't have to think anymore. If it sieves through that, then I go, aha, and then people have different versions. Most people, it's artificial flag, clicks next, but some people, it's natural flag. That sieving technique is a metaphor I think really works well for the way our brains naturally work. They just do that. Well, so happens with arrays, the same thing. And the first array is not going to be general. The general is the one that's going to slide to the bottom. If it's not one of the specialty ones, it's a general one. So good. Now, by the way, some students automatically catch that and do. So they can come up with their own sieve. But the fact comes out to be is they need to think about this. Now, what is the next one? The irony is the tally array, when I used to get problems and gave them 5 problems to choose from, I always set it up so they had to do 1 tally. Because the number of problems they had to choose from. The problem is they would screw it up, or they would do anything and everything to avoid the tally array problem, because it seems like it's the most complex, and they would rethink it over and over and over. And right now you're going, tally, what are you talking about, tally? We'll get there. Because the situations look different, but they happen to be exactly the same problem. What's rather interesting is that tally array is the most consistent, easy algorithm there is. And yet students didn't see it because I didn't show up to them. I just threw them problems and said solve. And last is the Boolean, which one also has its categorization. So here we go. What the heck we got about a tally array? So let's do this problem. What would you do if you did an election? What's the first part? If I had 5 candidates, here we go. I have 5 candidates running for election. I want to know who won and who got 2nd place.
Well, you're doing a lot of tallying.
Oh, yeah. What do you mean by tallying?
You're counting up how many instances of a specific name arise.
As a matter of fact, we might, if we're doing this hands-on, we would literally do it on the board, right? I'd set it up and set this up, and what would they do? They would do tally marks, right? I mean, if we're running an election, they'd pull out our name, and put a 1 for this, and another 1 for this, and a 1 for, right? That's what we would do. And we notice what I love about computer science, and love about every subject. I hate the SAT. I think it's the stupidest test there is, and thank goodness there may be a reason for getting rid of it now, not because we should have gotten rid of it a long time ago, but because maybe this is going to be one of the good impacts of the virus. We can't do big groups, so we're going to get rid of it. But the fact is we can prep vocabulary from day one, not by making kids memorize terminology, but by using it ourselves so much in context that all of a sudden it starts making sense. Tallying something most of us know, but there's a lot of kids, if you said, I'm going to tally up stuff, they go, what are you talking about here? I don't, because they haven't dealt with things that way. So there we go. So I would tally up that stuff and go, now hold it. Therefore, here we go. Here we go. Come on, you really sucker. For some reason, I don't know whether it's because I'm doing other things. Why is that? Maybe on the different screen. I bet that's it. Trying to get it. There we go. All right. So please tell me, what would I have for? Oh, first of all, everybody got it. We need an array, right? Everybody with me? Because of our rationale. So here's my array. I have 5 candidates. Please tell me what do I need to label here?
Need a name for the array?
Okay, and what would the name for the array be?
Election.
Ah, good. I like that. Good.
How about number of votes or something?
Because it's great. Election, or what's another name?
Number of votes.
Number of votes. Oh, let me quiet, Rosanna. We don't want to give answers away. Or what's another good name? Almost. By the way, think as your student. I always tell adults. Don't answer like you would, because of course you would have the right answer. I want you to answer like
candidate
your students
list
would, because of course that's what you want to hear. You would never say this, but what would your students say? And what was I think I heard it?
They'd call it list.
List? Oh yeah, they would generally. That's because what the textbooks do. You're exactly right. Okay.
I'd call it tally.
Kat, you said yeah, okay. So we call there was tally, list, election, was it
Nums.
num votes or something like that?
But this
Num
isn't gonna
votes.
hold.
And by the way, one of the most common, probably the most, is the orange showing up at all? No, it's probably not some reflection there. Canned is one of the most common. If I just let students do it, almost everybody does canned. If I look at the AP test, it would be the most common variable used for this variable. Now, by the way, which variables up here sucked pretty bad, and why? These are your students' answers, not yours, of course. So, okay.
These
List.
aren't tallies.
List is, why is list bad?
Too
It's
generic.
vague.
It's generic, it's too vague, it doesn't have any meaning at all. Good. Other ones,
Tally.
why?
It's not tallies. It's names.
It's what?
It's names of candidates.
Oh, no, we don't, do I care? Oh, I'm sorry, my problem was I want to know the number of which candidate won, Michael, because we don't know how to do strings yet.
So tally is not bad. It's just not specific.
Okay, yeah, tally may be okay, but if for some students it may be perfect, right? But yeah, it may be a little too generic here. Yeah,
Votes or num votes was good.
yep. And num votes or votes are good. Why?
Well, you earlier drew a name on the top and a name on the side.
Yep.
The side represents the candidate numbers. And so if we were to put this in a phrase, what this is trying to hold on to is the number of votes for the candidates.
There we go.
Number of votes for candidate 0, candidate 1, etc.
If you verbalize it that way, by the way, one thing that helps students, I was astonished the first time someone said to do this, and I went, why? And I did it, and like half the class got it. If you put something in here, if you put a value, 16, 22, 8, 45, 3, If you do that, you say, what does this 45 stand for? Does it stand for the candidate? Does it stand for a list? Does it stand, do you see? No. What does the 45 stand for? You
The
have to-
tally of the number of votes they got.
There we go. So you could say tally or just the number of votes, but it doesn't stand for candidate at all. And by the way, that is the most common variable chosen by students would be candidate.
But election could work.
Yep, election could work. You see, once again, is there an answer? No. There's a whole lot of possible answers, but there's also a lot of answers that are really pitiful. So you have to be able to justify that answer or make sense to you personally relative to that. And I like what Judson said, it really helps to have something down, and I'm going to just abbreviate it. So this is num or votes for candidate. And if you could verbalize this, I always said, and I like Judson used a version of that, but I always say, and this is going to be really important when we get the syntax in a second. If you could say votes of candidate is 45, so votes of candidate 2 is 8. If that makes sense in English, you got great variables. And it's also going to help you write the code unbelievably well. And you're going to see that in a second. All right. Now, if we did this, now follow with me and we're going to go this and then we're going to take a leap from here. What's the first part that I would need to do on this election? The very first part now. So we have the idea, we have this nice chart, we know where we're going. So when I start this thing, those are my variables I'm going to use, and we'll talk about the syntax and get it going here. But let's first of all talk, you're going to discover the syntax of this is insanely easy. It's so short and sweet, it's unbelievable. But the concept, the algorithm, the pseudocode, is the thing that students are going to stub their toe on all over the place. So what's the first thing I need to do if I'm doing this election, unless it's in Georgia? Or Florida, perhaps.
Create the list.
What's that?
Create the list.
Okay, so we got this. The cool thing is, since this is, we don't have to worry about that too much in Python, about declarations and stuff like that. We'll talk about that in a second. We'll worry about that. We did. We made that on the board. Good. Exactly right. So we got to title it correctly, the address and the title, and get that clean. Now I'm running this thing. I want to run an election. So what's the first thing I got to do?
Get tallies.
What do you mean?
As long as some value is not, as long as the flag's not triggered, then we need to get information from users.
Okay, well, I'm saying I've got to do something, and you're exactly right. In many places, and that's what they're worried about in elections, especially if you're using a computer to do it, what you just said is where people start. Because we actually need to start before that.
I'm wondering how we're going to ask for the information we want from people.
Yeah, once again, you guys, I'm not talking about coding at all. Right now, right? We're talking pseudocode. We're saying I want to, I always say, if I can't explain how to do this thing, there's no way I'm going to tell the stupid computer how to do it. So we need to sit down first and say, how am I going to do this process? I'm not thinking about code. I'm not talking about loops. I'm not talking about any of that junk. I'm saying, I made this chart. I'm running this election. What's the first thing I need to do before I even start getting votes or anything else?
Well, I think you need to know which cell represents which candidate.
We got, okay, well, here we go. Well, we're not worried. We're doing this hidden. So, right, because if think about this, if you think about when you run an election, right, in the old days, it was kind of fun. Do they care about the name, Mike? When you actually on our ballots, when we do our mail-in ballots, which of course is unbelievably pitiful, terrible, terrible, terrible thing. Anyway, when we do our mail-in ballots, do they care about the names? Is the names attached to anything I do? Does the computer care about the name of who I'm voting for at all?
The computer doesn't. I mean, it's written on the ballot, but the computer doesn't.
The computer doesn't, the name is not attached to that, right? What is attached to the ballot, to the person, to the candidate?
The bubble placement.
The bubble placement, right? Just that number. This is bubble 0, 1, 2, 3, or 4. That's it. So we got that down. So we're going to be voting for that. But we are too far ahead, guys. One thing we need to do first, we need to start there. Unfortunately, in some places that may not be the case, but we need to start there, right? If we don't start there, we don't know where we started from. So the very first thing I need to do, just like, and by the way, if this was a broader context and we were teaching an entire course long, we talked about initialization so much and pushed that issue with other variables so much that here it would be a more natural step. But the first thing I need to do is I need to initialize my array. I need to make sure everybody starts at 0. Correct? Now that I got this, what do I do next?
We need to figure out some sort of case by case, or if such and such thing happens, then increment,
Okay.
position 0,
Okay.
position 1, and so on.
Now, once again, don't worry about computer programming right now. Do exactly what you're saying. So exactly right, Johnny, what you're saying. So do an example, run one through. So tell me, what would you need to tell me if I'm running the selection for you right here on the board? What would you need to tell me? Do an example here. Come on.
How many people are running?
Well, I got 5. I told you, yeah, there's 5 people running right there. So the 0 through 4.
You'd have to say
All
who.
0.
You'd have to say who got which candidate received a vote.
Good. So you'd vote. Someone would come in and vote, correct? So tell me, Charlie, how can we vote for somebody?
Well, you would put a check mark in box number 2.
All right. So you're telling me you voted for 2. So
Yes.
you would give me what? Now think about this. This is what I'm trying to get you guys to do, right? You would be telling me what?
You being who, really?
Well, what 2 stood for what?
For the 3rd candidate on the list.
For candidate number 2, right? There we go. Exactly right. So you told me you voted for, notice I'm doing this kind of on purpose. You voted for candidate number 2. This is going to be important when we get down to coding. Because it's not what students do. You voted for candidate number 2. And what did we do? We went to that spot, exactly right, and we
Added 1.
good. I was waiting for somebody to just say, we put a 1 in the spot. No, because the next time someone voted for 2, I didn't just put a 1 in the spot. I added 1 to what's in there. And you guys talked about that. So good. I added 1. Cool. Now what? Keep going. Now I got the rhythm.
Next vote.
So give it to me.
They vote for candidate 1.
So
We add 1 to candidate 1.
good. Keep going. You see what we're doing here, folks? And by the way, some of you are already figuring some things out, and a whole bunch of that is probably wrong, which I love. But that's okay. That's exactly what I want to be happening. So keep going. So we keep doing this process. Do we know? So we got another person voting for 2. Now we have one person voting for 4, another person voting for 2, and so forth and so on. Correct? Now, do I know how many people are voting here?
No.
In most counties, no.
So there's probably an artificial flag situation.
There are. Now you see what we're doing here. You see what we're talking through by doing this hands-on. A whole lot of stuff should be smacking us upside the head. But we are now inventing the vehicle. We're inventing, we have a new problem, so we're not reinventing, but we're inventing this process, correct? I don't want to have to do this with every problem. So I want to see if there's a pattern here that fits a category of problems, and that's what we're kind of developing here. First of all, we got to get one, and then we say other ones like it. So here we go. So we kept doing this over and over and over again, and it's going to be an unknown because I don't know how many people are going to vote. And then we got it.
I want to vote for 5.
That's nice, Michael. You would. I know you well enough. That's the case.
Don, his
have you
name is-
restricted. We have you restricted, and you can't do stupid things. So we just reject your ballot. It's a hanging Chad, so you're on the outside.
His name is Obob.
No, Bob. Yes, there we go. We'll talk about that one later. Yes. So we have preconditioned all this stupidity. So Mike's been, you know, he had a literacy test before the voting, and so he could not vote. So I'm sorry. Here we go. He didn't pay enough money. So all right, here we go. Now, what do we've got going here? Everybody following this process? So do we need to, right? I always call it the rhythm of the problem. You keep doing this until you got the rhythm of the problem. I think we've got the rhythm of this part of the problem. Everybody with me?
And
So
now
what's
I'm
that? So we admitted it, and then we ran the election. We run the process, correct? Now, when we're finished that, what do we do?
We need some way to say voting's closed.
Okay, well, the last voter, when it comes into a -1 or a 5, so when we have that happening, it shuts off the election and we're out of here, correct? Cool. Now what?
Then we need to see who won, right?
We need to find out who won, which is the algorithm. If you look at it, we talked about this relative to the constructs the other day. On Monday, they were in a list. We never got around to doing that stuff. We did, but we're looking for the max min, right? The max min is an algorithm. So we are going to find the winner. So what we are going to do, and it relates back to this, the terminology you did before, we're going to use our data, in this case, to find winner. And we are also going to show all. Right? We would show everybody, and then we would show who won. Make sense? Okay. Now, let's take a second. Does everybody have the rhythm of this problem? Everybody see what we got going here? Now what we're going to do is we're going to write this out like a score of music, right? We've done it. We got the idea in our mind. We got the whole structure. I want to write this out in pseudocode, not code. I want to get real close to it, but I don't need to get all the way because you'll discover that the code is real simple. We'll talk about that in a second. But what we're going to do is we're going to do these process. Now, with this board the way it is, can I erase this? And everybody, remember the chart? We have votes of candidate. That's what we chose. Okay? So to initialize this process, did I have a loop? Yep. What type of a loop? Because I need to put zeros in all those suckers, right? What type of a loop?
Artificial flag.
Careful. To initialize, to make them all 0.
Oh.
Do you really need a loop? Don't you just have to make a list with 5 zeros in it?
Okay, now, good. Now, Regina, once again, you're diving into syntax. And by the way, that is a radically different statement depending on what computer programming language you're using. And the fact is, I'm not teaching Python, I'm teaching programming. I'm going to give you the syntax of Python and I'll show you different ways. But the fact is, depending on what language you have, most of the languages, the answer to your question is, no, I must set them all to 0. As a matter of fact, in C, if I didn't set them to 0, they would be set to any value, positive or negative, all over the place. Any negative large int. And so therefore, we would have really wacko potential here.
Right. So Don, are there languages that distinguish between, okay, so I don't know enough languages to know the answer to this, but do you have to prescribe the length of the list at the beginning of the program, or can the list have a flexible size? And does that matter by language?
Yeah, it doesn't matter by language. Java expands if you use a specific type of list. C++ is insanely concrete. We call it static versus dynamic, and they're radically different between languages. And once again, that's a specialization that we will talk to when we get to Python. But the fact of it once again, I don't want to worry about or thinking about that, because whatever language we're teaching kids now is not going to be available by the time they graduate from college, or there's going to be a better one probably. So therefore, relearning and knowing the basics, like I said, our son jumped to C# and never knew it, and knew more than all the other people within a month because he knew all the foundations. That's what I want to do at this stage. By the way, that's why if you guys know your community colleges or four-year universities, if you paid any attention over the last 20 years, it's insane what they use as their intro language for a computer science degree. For many years, probably a decade, that's AP was in Java. This because Java was where everybody was going. All the universities went Java. And then they didn't. And now there's so much variety. Many of them go like to C, not to C++, even to C, because people were using tools like you're talking about, Johnny, the ability to iterate, expand. People were using tools without knowing what they were doing at all. And so they were picking up a hammer to put in a screw. That's literally what was going on. I mean, quite literally. And the programs looked exactly like that. And because they were using hash maps instead of tree maps, because it worked. And that's what was going on. So the professor said, this is garbage. The employer said, this is garbage. And they went back to C. And now that's garbage because the poor students, they now wipe out all the young women and anybody of diversity, because unless you had a lot of, if you were so anal that you just love to do coding no matter what, then you are a programmer. Otherwise you quit. And so therefore, instead of teaching Java right, they went to an easy place and did something else. So you're right. But in this case, what I want to do is I want to go core. How do I make those suckers all to 0? If I have a chart with 5 items in it, what do I do? Do I have a loop?
Well, you could do it explicitly by doing each of the 5, but usually the generic case is to use a loop.
Yep. And yeah, you could do one by one by one, but as soon as we did that, I like that, we would see the redundancy in it. We would say, nope, stop. And I'd also say, can this expand up to 20 real easily? Nope, I did not. So therefore, what type of loop would I use?
A for loop.
Okay, because I made my chart, right? My chart, I got to draw it on the board. It's there. Now, by the way, if I don't do it this way, you're right, Virginia will set that up later relative to Python and some other versions of this stuff. But the fact comes to be, if I said we have 5 candidates, we have to know that before we start the election. In other words, we got Michael doing his weird things here. So here we go. Or what was that Alaskan election where they had a write-in and the write-in won, and then the person who lost complained because people spelled the write-in name differently. So therefore, they said that the different spellings were for a different candidate. And it went all the way up to the Alaskan Supreme Court, and they said, you idiot, you know they meant the same person, so no, you lost, this person won. But I thought, yeah, that's a game people would play. Yeah, there we go. So for loop, and then what did I do inside?
For numbers ranging from 0 to 4, make whatever the variable.
And
What is
so
our
we have
variable?
votes.
Square bracket.
Don't worry about syntax. Yep.
Oh, okay. Index.
Okay. And so what is going from 0 to 4 on our chart? This is good. This is really important. What went from 0 to 4 on our chart? I don't have it on the board anymore. But what
Some counter.
candidates, right? Not votes, but candidates. So for our candidates, went from 0 to vote, the votes of the candidate equals 0. Everybody see that? Make sense? Now, by the way, tell me, I don't give a rip whether this Python processing, C++, Java, probably JavaScript. I don't know enough about JavaScript to do it. This is it, right? This doesn't make any difference at all. We've got this. Everybody with me?
We can't see the board. Oh, wait, sorry. I see it now.
Okay, good. I'm frightening. Okay, all right. We got it? So that took care of initializing. What about running?
That's where my artificial flag while loop comes
There we
in.
go. So we had an artificial flag, and our artificial flag was get flag variable while flag variable doesn't equal flag, do stuff. I always just do squiggle, and then get flag variable again, correct? Cool. So now what did we get from the user?
It's we need an input. We need them to write in who they're voting for.
Which was, careful, and what was who they voted for? When we said
So-
circle, what was that?
We need them to share a vote
Careful.
for a specific candidate
So
number.
what did they give me?
A number, unless we're going to assign
No,
those variable. Yes, they're going to give us a number
and that number was for what?
between 0 and 4,
Which stood for what?
a candidate.
Thank you. Not a votes, not the votes. Do you see do you see what I'm trying to get to? They gave me 3, which stood for candidate 3. That's what we got. So what is
Well,
that?
I was trying to structure it like you were saying. So a vote
Yeah, I know.
for a specific candidate.
Yeah, exactly. There we go. So our flag variable was the candidate. So I'm going to get a candidate. Correct? And then what
Yes.
did I do?
You would make vote of that candidate
Well,
go up
we'll get
by
there.
1.
Don't go too much syntax. Yeah, but you're right. We'll get there in a second. Before that, while this candidate didn't equal
The
Make it
flag,
one
whatever the
flag,
flag is. Whatever our
Mhm.
flag is.
Yep.
End
And
of
then Johnny,
voting.
then you would say, we said vote of that candidate, what?
We want to increment the vote for that candidate number by 1.
There we go. So we go vote plus 1. Everybody see that? Notice no code, no syntax. We have the concept, and what do? Then we get candidate again. Pretty short and sweet.
May I ask something?
Yep, please.
While I'm listening now this, I was thinking about the matrix 2 by 2.
Yep.
And I was thinking if we had a matrix 2 by 2 and we had 2 counters, one for the candidates and one for the votes. So let's say if I represents the candidates, let's say, can take values from 0 to 4, and the other counter will be for the votes, so it will be from 1 until the number of the, of the sample, and it will be the votes. There I'm trying to think how I can add now. I mean, let's say if someone votes for someone, it will be one vote. So if we put a counter, having counter plus 1, I think it will be good idea. I don't know, just I'm thinking all this stuff now.
Well, when you talk about multi-dimensional arrays, and we'll have to talk about that later, matrices are capable of being used all over the place. In this instance, since your row, your first column would just be the candidate 0, 1, 2, 3, or 4, it has no purpose. Later on, matter of fact, with Python, with Java, with C++, you would actually create an object, a class that contains the name of the candidate, the number of votes they have, the party they belong to, and whatever information you think matters to know about a candidate. And it would have that information, and we would increment just the num votes field of that class, of that object. Yeah. And therefore, we would avoid doing multi-dimensional arrays. We don't tend to, if we talk about multi-dimensional arrays, we'll talk about where that can be used. But in this instance, number one, it's making it too complex where we are right now. But number two, it actually isn't the solution that would be best applied to this process. There's other tools that are better.
Okay, thank you.
But to follow up on Nikos's question, it is possible to do it with a 2-dimensional array. It may not be optimal, but you can,
yeah.
right?
Oh yeah, yeah. Like I said, multi-dimensional arrays are out there all over the place. It's just in this case, it probably would get more confusing than it'd be better. So I want to get past, because we have about 10, 15 minutes on to get this. Does everybody see that this would be for the election that will work? Have you written it down? You got that? Although on my note sheet, we'll talk about where it is there too. Okay. Now, how would we use this? So we've now initialized, we've run, and now we're ready to use. How would I do that?
Officially, it's a problem of maximum and minimum there.
Yep. So I want to know who won. So in order to win, do I need a loop? I had 5 candidates, or well, you're shaking your head no, Kat. So what is your solution, do you think?
Well, I don't think you need a loop. You just need to call whatever the winner is by finding who got the maximum number of
How do you
votes.
do that?
That is a great question that I don't know the answer to.
Okay, good.
You can cheat and use dot max, the function.
If there's a tool, and we're going to get to that, that's why you may notice for Johnny, I've not taught the general list properties in Python yet. I avoided that in this conversation. In Python, there's a nice little tool that comes at, but the fact is, I need to know how that works. If they're going to do a max, that's cool, but I need to know what's under the hood because I'm the programmer. I'm not
So-
the car. I'm not washing the cars. I'm repairing the cars. I'm building the cars.
You have to check, start with the first one and check to see if it's bigger than the last one or the next one. And if it is bigger, then you check to see
I
if it's
agree.
bigger than the next one and just,
Good
Okay.
idea.
So in order to
Good
do
idea.
that, do we need a loop? Would it be better? And by the way, it's easy to say, expand this to 10 candidates or 20 candidates. When we want to do whatever your process is with 20 candidates.
Yes, we would need a loop.
Ah, there we go, right? It would make it a lot easier, put it that way. Everybody see that? What type of a loop?
A for loop, because we know how many candidates we have.
There we go. Interesting. Notice what we've done. To initialize, we did a for loop. To run the process, we did a while loop. And now to use the data, we used a for loop, because I'm going to go through things all the way. That's interesting. Just a little foreshadowing here. All right. So the for loop, we've got, there's versions of this. There's variations all over the place, but let's not get hung up on that. We have a for loop. And what's controlling our for loop, by the way?
Number of candidates.
What controlled our initialization loop?
Number of candidates.
Thank you. Oh, by the way, what controlled our run the process?
Voters.
No, careful. What controlled, what variable, what entity controlled the loop that was doing the voting, the process? It was, what was our while loop based on?
It was votes, right?
What did the person type in? They typed in a 3. What did that stand for?
it was the candidates.
Thank you. It was the candidates again, wasn't it? Now, by the way, what you just did is exactly what students do. We're going to talk about that bigger. It's a bigger issue than what you're saying. In all honesty, the irony is that all loops based on this process were based on the index. The index, the address variable, controlled the loop. And that is not natural. I mean, it doesn't seem obvious, especially running the process. It screw up constantly. You see what we're doing? Now, think about vocabulary. Some people don't like algorithms because they say, that's stupid. You should understand stuff. I go, hold it. Yes, that's our goal. But when we're learning French, we don't understand French day one. We memorize words. We use them over and over, and soon we begin to understand how to do that. So memorization is not a bad thing. It's a stepping stone to a better thing. And it's nice to have a stepping stone to get to so I don't fall in the river and drown before I get to the other side. To me, that's the purpose. So in this situation, this using stuff as a for loop, and yes, we're going to do our max min. We'll come back to this. If I'm going to do it, I'm going to do a max min. If I'm going to just show everything, I'm going to show them all, right? I just do a print and show the person. And what am I showing now? I'm showing the votes of the candidate. And what did I compare when I did a max min? I compared the votes of this candidate to the votes greater than, less than, whatever votes of another candidate. Correct? Interesting. So inside the loop, we had some similarities too. If you'll notice, every site initialized, we made votes of candidate equals 0. Running the process, we made votes of the candidate +1. Running the stuff, we did votes of the candidates, comparing it to somebody else or just showing it. Notice we have a lot of patterns that, in all honesty, if we jumped right to syntax, students would not see. And what's weird is, and we'll get to this stage of this time, You know this election problem? This election problem is 100% exactly the same as an inventory problem. It may not look like it, but it's exactly the same thing. But instead of votes, it is quantity. And instead of candidate, it is item. So we have quantity of items. There we go. Now we may have two arrays. We may have another array called price of item if I need to take care of that. Or going back to what Nico was just talking about, if I got it, I would make an object called item that would have number and price and name all built into one. And so I would have item, I would have product and number, item number. That would be the address. And it would work exactly the same as this. You know what's really weird? Mode is exactly the same as this. Matter of fact, it is literally 100%. Is what is mode? It is the best one. You want to get your, when Johnny, you're talking about students who are hot dogging it and being smart mouths, tell them to solve the mode of a problem. And they will dive and work so hard. And the mode is 100%. All you change is the variable names from an election. Why? Why is mode and election identical?
Because we're looking at the highest frequency in both cases.
And that's all it is. The mode is the number that won the election. That's all it is. And I love them, the mathematical kids diving around making this thing so hard, when in reality it's the same thing. So notice what we did. You may not have got this yet, we're going to do syntax, but what I've just said is that every single tally problem, any type of problem, are sieve, right? We haven't even talked about syntax of a list yet. We haven't even got, by the way, that is the easiest part of this whole puzzle. But in the sieve, if I put the problem in there, if it is a tally problem, if it is an inventory, mode, election, or any version thereof, here's our 3 steps. You initialize with a for loop, you run the process with a while loop, and you use the information with another for loop. All the loops are controlled by the address. And inside all the loops, you use the name of the thing, votes of candidates, and do the process. Therefore, when they do these, they never have to reinvent the wheel. Here's your apples and pomegranates. Every problem that has a tally array works like this. That is more important than the syntax. And we're going to go to the syntax now the last couple of minutes, and then next week we'll focus right on that from the beginning. But the fact comes to be is you guys can learn all the syntax you wanted on a list by looking in any book or any other place. They're just listed there. But the fact comes out to be what we just talked about, this process, and we haven't got to the Boolean array yet. That process is never shown anywhere. It took me many years to figure out that I need to be smarter than the books. Well, no, let me rephrase that. I need to be a teacher, not an imparter of information. And that's what we need to do. Okay? So now, the last couple minutes, if you got code in front of you, if you have the code listings that I sent out the very first day, you can look at the list code. And I'll get this up here a second. I'm going to share this. I'll share the screen with you guys. And I will put up this list code and I'll do its execution. Okay. So what we have here, if you look at the code called, it's called 7.list commands. It was right here. We will now start talking about some syntax. And this is when Johnny was talking about, several people wanted to do it, and I'm going to show you both how to do it in Python, how you can set it up without loops, and what we can do with loops and so forth. Okay. Now, does everybody either have code or are you seeing the screen? I think everybody's seeing the screen now with the code and its execution beside. Okay. So at the very top, I have, this is by default, you can set up in Python. You might look at list 1 and say, that is really weird, and you are 100% correct. They're Java, C++, C#, none of them can do what Python can do. And that is make a collection of really disparate. Here we have strings. Those are words like inside of our print statement, either single or double quotes, and also numbers. Python can do that. I'm not suggesting you do that, because it makes the algorithm, as we alluded to earlier, really weird. But since someone brought it up earlier in some conversations, I added it into the stuff. Most standard, here we go. List 2 is a list of numbers. List 3, a list of letters. And list 4 is just a null list. That's how you create a list with nothing in it yet. Okay, questions about making a list. Now, by the way, we'll talk about how to add to or make a list like we did. When we put zeros into it, we'll show you that in a second. By the way, what's cheating it is Python, unlike other languages. Python, notice the next thing. Under number 1 here, and over the execution, I printed it. You can do in Python, you can print out an entire list by just its name, by just its title. And Python will print it out just like a list. This is literally when I run this program. If you want to see it, I'll just do it here. I'll close this off. If I run this program, there it goes. There's nothing tricky I did here. We'll come back to this in the latter part later on. That is exactly what it outputs. So that is cheating. By the way, Python, once again, you could use this tool, but it is not a good thing to depend upon because other languages don't possess that. Okay, it's like, do I start a sentence with a but or an and? Well, you can, but very rarely, and most often it is wrong. So learn how to do it right first, and then we can learn the tricks and when we can do some other tweaky things with it. All right? 2. Here is, if you look at it, list 2 was our list that we had the numbers 1, 2, 1, 20, 13, 4, and 5 in it. The way to add to a list or an array in Python is the command append. By the way, if you have this sheet, the notes that I gave you for today, there's a bunch of commands listed out. And you can look at them, or you can just look over here and highlight this depending upon what you printed out for yourself. But append is a nice vocab word that we learned to use. Append adds to the end of a list. And we'll talk about why doesn't it add to the beginning in a little bit when we get to that. That might be, you guys might want to jot that question down. The students are going to ask that question. Why doesn't append add it to the beginning? Well, there's a reason for that. And if you look at this, notice what I did here is I now printed it out because when you just do the full print, all it does is show the array, a list in that format. If I want to print out like 0, 1, 2, 3, 4 down the line, I've got to come up with my own version thereof. And so once again, I did a for loop in the range of, and notice what we have. There's a new command, a new function because it's in purple called len. Len gives you the length of any list. So the len of list 2 tells me that in this case, list 2's length is 5. So it's going to go from 0 to 5. Stop me if you ask a question. If you need it, I'm going to go through these fairly quickly. And then we printed out the num, 0, and the content, list sub num. So lists num in that spot. And then we could do the average. We added them up. That's how we would add up all the totals in our array. And then we printed out the total, dividing it by the length. By the way, since that's redundant, you may tell the students if you do it, if you have to do it more than 2 times, I tell my students, no, that's a dumb way to do it. After you've added everything, you should have a variable set up to equal that so it doesn't have to be recalculated multiple times. But right now you've learned append, you learned len, and we learned how to use an element in the list itself by going list sub num. And in Python, it's square brackets. In other language, it's parentheses. kind of like the square brackets because it delineates itself from the parentheses needed for functions. Now, number two, we can fill up the stuff replacing these things. Notice up here we appended, which means we added on to list two. Down here, we just say list two sub num equals this new thing. And what it will do is it will just completely replace the other stuff. It overwrites it. Going back to our terminology for word processing, you have the ability to overwrite any element in an array just by reassigning its value. List sub 0 used to be a 1. Now list sub 2 came out to be a random number, which was 4. Everybody with me? Okay. I would skip this for each right now. That is really handy for another process, but it would be confusing at this stage. It's another little handy tool, like just printing it out. Some of you who know other languages, the for each is kind of interesting, but I would not use it right now. And as Johnny's pointed out, there's another function called max built in. So literally it will do a max. Now, what is max doing? There's a built-in function, so literally tell me, what is max doing?
Finding the highest value in a list.
So what does the code look like?
You mean, what does the code for the function max look like?
Yeah, when they made this function max, what they do. By the way, what I'm asking you right now, it's interesting. One of the OCS, the workshops we were doing a long time ago, our president was the president of a big banking software firm. And I was teaching class, and we were really, this is one of the week-long classes, 8 hours or 6 hours a day. We were really into a great conversation. He comes walking in, and I'm doing something like this right now. And I thought, oh, shoot, don't say anything. Just, we're in a row. Just be quiet. Just sit in the back of the room and hand us the dollar to run this program and just stay out of the way, okay? That's my stupidity. But anyway, and he says, Don, let me interrupt. I went, oh, shoot, we're in the rhythm. No. He said, you know what? What you're doing right now is exactly the question I asked on an interview. And that is, we take a reserved function that is built into a language and say, tell me what is fine under the hood. So tell me, please, what would max do?
So first, I think you could set the first element of the list to be the maximum, correct, and then run a loop where you're constantly comparing the one element with the next element, and then swap the value of the maximum based on which one is greater.
There you go. So what type of a loop?
You know how many items you have, so
You
it's a
got
for
a
loop.
done. So we got a for loop. We either initialize it to the first element or initialize it to -1, whichever you got. And there's benefits to exactly what Johnny said. And then you, in the loop, you do a max min comparison where you compare and switch, and that's it. So guess what? That's the max. So as long as the students know that, then we can use max. If they don't know that, using max is a weakness. That's why they threw away Java and did C for intro languages at college now. Is Java had too many tools built in, and students didn't know how to make them. Next, append. We know that, right? We can add to the end. Deleting. Nice thing to do is.
Now I have a question about append.
Okay.
Temporary, not
No.
permanent.
Permanent. It changes the length of the array. Exactly right. In Python, now by the way, append is really quirky. Most languages do not have that with standard arrays. Standard arrays are static. They have concrete length. When you build them, that's how many spots they have. Python is different than that. There's a dynamic array. As soon as you append, it increases the length. By the way, it also has a delete. You can delete a spot in the letter, in the thing. And what you do is, you can either do it independent function delete list 3 position 1, or notice, and here's our example, Z, now what's position 1? Here's our thing right here, this is number 5 and 6. Here's our 5 with the letters ZK, HDT, and then I deleted position 1. So notice careful, as Michael alluded to earlier, and we'll talk about that next week, maybe an OBOB. Right? Position 1 is not the first element. Position 1 is the second element, because we start at 0. So you can either do 2 types of delete. One is a delete outside, which is just function straight up, or you can remove a specific item in the list. They are completely different style. Notice remove deals with the contents, delete deals with the address. Okay, so you may have to play with that later on and just check things out. Append, yeah, we did randoms. Reversing, there's a nice little thing called reverse, and it literally reverses the order. And yes, you should know how to do that without the command. You can't use a command unless you know. And I tell the students this every time. I say, do you need a question? Oh, no. So guess what my first test question is going to be? Write the function reverse. So anybody who paid attention and did what I asked, it's the easiest test question there is. Everybody else is now inventing the wheel in the middle of a test, which is terrible time to do it. Okay, and then we go on down the line and we can remove some other stuff. That is a general syntax of a list, and we're out of time today and we're past a little bit. We will come next week, review what the tally array is, and then look at the syntax. What you can do to make this quicker if you want, so we get further next week if you want, is look at the election code, look at the syntax, come back with specific questions, then we can run that one quickly and maybe get on to the Boolean and general elections, the general list problems next week. Questions, as if anybody's still here. I don't see screen. Oh, you're still here. Several of you are still sleeping, but that's okay. Others of you just put it on with quick light. I noticed that. All of a sudden your pictures show up. Here we go. Yeah.
Don, are you likely to address functions next class?
Oddly enough, functions are very, very easy syntax. If we want to, the next class, stop me at a certain point. If that matters, in like 10 minutes, we can explain functions. And let me rephrase this. One of the codes with arrays has functions built into it. Maybe we can jump to that and explain the functions as we explain the array stuff. That may be clear. So if you want me to, the answer is yes, you guys control it. If we haven't gotten to it, Radhani, if you want to pull it off like 15 minutes before the next class is over, tell me and I'll stop or wrap up what we're doing and I'll jump right into it.
Thank you.
Sure. And as Justin alluded to, it depends on what you're doing. To me, functions are clear, they're easy. The syntax, there's no tricks to them. You can learn them on so therefore that's why I haven't done it now. As Justin said, many teachers teach function way back in the beginning, and that's cool. It's appropriate. I tend to like to do it a little later when it has when the students say, hold it, Kirkwood, this is really getting weird and confusing. Can I split this up? And I go, yeah, let me teach you functions. But it's all a frame of reference. I don't think it matters much when we're doing it. All right. Anything else? Should we go to the order just before we shut everybody down? Or you shut me down? One of the two, I guess.
No, thank you for class today.
I hope this, I know for some of you this is way past, but I hope you also say it's not that hard. You know, you haven't done this, but in reality, yeah, I can pull this off with a little bit of practice. We can do it. And other people, I hope you say, oh yeah, the syntax is easy, but I never thought about that. And we'll put all that puzzle piece together at the beginning next week. All right? Thanks for doing it. And think about also, like as Donnie pointed out, if there is some, you guys have meetings and homework and you have wacko schedules with doing this stuff online. So it may not work at all, but if some of you want to get together, think about that and frame, maybe start chatting back and forth in email, going back and forth this way so that we can look at it and see if there's a time. There are some days I have trustees and I have other meetings that I go to that I can't do it there, but if this would be a priority for me, put it that way. I think this would be cool to continue what we're doing. Either with topics saying, Kirkwood, can we discuss this for a half an hour? Or just general, you have a place to scream and yell and I sit back and go, as my wife was in elementary said, oh, yeah, that's real, I understand. As I'm sitting home eating my bonbons, watching soap operas. So sorry. Yeah. All right. Anything else? Okay, thank you. I hope we are doing what you want. And we will see you next Tuesday. Tuesday next Tuesday we may get the functions. That might be a really appropriate leaping point because we'll finish up constructs and do that stuff. You know, and Johnny, that might be a real good place to interject functions because that would be a simple, clear, straightforward way to do it. And maybe we'll do it there and that may cover your topic for you.
Okay.
All right. Have a good one all. If you have anything else, email me. More homework list. I will be kicking something out to you with hard runs, and then we'll go from there. All right.
Thanks,
Have a great
Don.
one all.
All right, everybody.
2 hours is about the limit of what my brain can handle. So thank you.
Yeah, like I said, it used to be 6 hours a day, 5 days. That was pretty killer, but yes. All right. Have a great one all.